The SoftHand Pro is an anthropomorphic artificial hand that is used for prosthetic application. The hand was developed by IIT and in collaboration with the University of Pisa. And behind this work, behind this hand, there are technologies and studies that comes from both the robotic and technological side and neuroscience. Indeed, two of the main aspects of these artificial hands are the use of soft robotic technologies. This means that the hands have fingers and ligaments that are based on elastic joints that resemble and mimic in some way the structure of the human joints. And the principle that is behind the actuation of the hand, the movement of the hands, is inspired by studies by neuroscientific studies that explain on how the human brain in some way control the complexity and the organization of the fingers of the human hands. Thanks to these technologies and investigations, we come up with a hand that is simple in the actuation. Indeed, the hands have just one motor, but have the complete architecture of the human hands. So basically have 19 degrees of freedom, exactly like the human hand. And the hand, another characteristic is that it is extremely robust. This means that it can interact with the world, with the environment without breaking and without damaging the environment or other people, and can be controlled in a simple way by users. Our experience in Cybathlon started in 2016 when we participated with at the first edition of the Cybathlon, and with a first release of the prosthetic hand that was controlled by a body power mechanism. After we followed all the development of all the path that bring us to the Cybathlon 2020, where we participated with a new team and a new release of the SoftHand Pro that is totally myoelectric. Our team is composed by engineers in the field of mechatronics, computer science, and electronics, by a designer that is also our pilot, and around this core team there are many other people that work on experiments, testing, and developing adaptation of the prosthetic device for the competition. Behind the development of the SoftHand Pro, there are several funding projects that comes from the European community and also from private funding. And just to name a few, the most important are the Soft Pro project and the Natural Bionics project that is an ERC project that is currently running in IIT.
The SoftHand, thanks to its main feature, the adaptability, allow the user to maintain natural behavior and a natural approach in interact with the environment. That means on the first trainings we asked to Maria just to try to solve some tasks without further suggestion, and we, through observing her and listening to her suggestions, we redesigned the hand around her needs, around the user needs. When the work on the SoftHand was finished, the real training began. And as training, I mean not only a physical training, but also a psychological training. That means we not only repeat hundreds of times the task of Cybathlon to speed up and refine every steps, but also we conduct some stress tests to simulate the stress mood of a real race. Such as all race, the pilot's mood it's very important on the final performance.
I am Maria, the pilot of the SoftHand Pro team who took part in the Cybathlon 2020 Global Edition, and we really used a user-centered approach in training for all the tasks. The first task, the breakfast one, was really natural for me because there were no blue object. This means that I could use both hands, so like in real life, and so I really showed to the rest of the team how I usually do things at home, and was really like performing a real breakfast at home. So in training the clean sweep task, we really try every day to have a safe task, a safe modality to grasp the objects, different little objects, and to feel comfortable also in doing it. And we made it. We really do it fast and in a safe way. And I want to make a third example about our user-centered approach, and was about the stacking, the last task. So about this pyramid made of glasses. So for us was really hard, and we really trained a lot to compensate all the movement that the prosthetic hand could not perform. This means that we had no an active wrist, so we had no pronosupination of the hand. We have it actually, but it's a passive movement, and so it was really hard for us to perform all this compensatory movement with the body. And we took it as a sort of dance in training to really have at the end a really smooth movement.
Some of the tasks of the race are challenging to us. Those are very important for us because they also show where the directions of our next research have to be. For instance, the contemporaneous and simultaneous control of motions of the hand with the wrist in some operations is difficult operations to realize with a smooth, seamless interface to the user. A second point is the use of grasp that also involves the palmar arch of the hand that is needed in some cases. And finally, of course, is the rendition of tactile feedback from the hand to the user. These are directions of future research that we are going to implement next time.
Behind the development of the SoftHand Pro, there are not just engineers but also users that have a fundamental role in the developing of the SoftHand. Indeed, during the last years we did many experimental activities with the users, with the end users. And this for us was a big opportunity to validate our ideas, but also to improve them and to put inside the project new concept and new features of the hand. Example of this interaction, continuous interaction with the users is the developing of the control strategy of the hand, but also the developing of the features, the glove and the external features of the hand. In this way, we were capable to have a cosmetic glove that mimic the texture of the human skin, but also to have gloves that are more aesthetic and more functional in some way during the interaction with the environment and with other people. Another important aspect that we found really interesting in interaction with the people, with the final users, was that we understand and discovered the new functionalities of the hand. First of all, we understood that thanks to the softness, the hand is capable to interact with other people, but is also a useful tool to interact with the own body of the user. This means that people that use this kind of the hands are capable to touch their face or touch the other hands or their body. And this we think that is really a backdoor to improve the embodiment of an artificial devices inside the body schema of end users.